In this introduction to image processing, we are going to see about definition, applications, elements of visual perception, image acquisition system and process, and basics of digital image. Applications of digital image processing. So some of the applications we can see here is image sharpening, medical field, remote sensing, transmission, machine and robot vision, pattern recognition, microscopic imaging. So everywhere we can see, especially we are familiar with some of the medical terms like PET scan, X-ray, CT scan, UV imaging. So these are also some of the samples of digital image processing applications. So we can see now what is digital image processing. Define image processing. Field of digital image processing is built on a foundation of mathematical and probabilistic formulations. Human intuition and analysis play a central role in the choice of one technique versus another, and this choice often is made based on subjective and visual judgments. So in this image we can see an aerial view of any city. So this is nowadays very useful in analyzing any particular part is getting affected or not. From everywhere we can know this is a useful information. Immediately we can then and there we could see the information from these kind of image processing techniques. In the field of remote sensing, the area of the earth is scanned by a satellite or from a very high ground. It is analyzed to obtain information about it. To detect the infrastructure damages caused by an earthquake. So the key steps are extraction of the edges and analysis of the enhancement of various types of edges. So we could see some of the examples of original image and a zoomed image and a blur image. And here is the example for a sharp image and only the edges. So what is meant by elements of visual perception? Okay, every human have their own visual perception in seeing any object. This is the cross-sectional view of a human eye. Here is the image formation in the eye diagram, graphical representation of the eye looking at a palm tree. So we all know that we have studied in our school itself that when we see an image, it will be stored as an inverted form at the behind of the retina. A person is looking at a tree 15-meter height at a distance of 100 meters. So if the height of the object in the retinal image, H denotes the height of the object in the retinal image, and then the geometry of the figure yields 15 by 100. For example, if the height of the palm tree is h1 and the image formed at the retina is h2, so how we can form is 15 by 100, the distance d1 equal to h2 is unknown, how much size, how much height it's going to be stored is unknown, h by 17. 17 is the distance from the C2 and the back, this edge. So 2.55 mm is the answer. The retinal image is focused primarily on the region of the fovea. Perception then takes place by the relative excitation of the light receptors, which transform radiant energy into electrical impulses that ultimately are decoded by the brain. Image acquisition system or process. So the earlier days, how the image have been acquired using a single sensor. So when the sensor takes the linear motion, one image line out per increment or rotation. So we would have seen a old camera in our house. In earlier days, the film is being inserted into the camera. For every click, every single image is taken. And for another click, another film will be coming into the roll, and it will be taken as another image. It is used for taking another image. Incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is responsible for the particular type of energy being detected. Next, if we have a circular motion, how the film is carried out. Image acquisition using a linear sensor strip, image acquisition using a circular sensor strip. So these are the two different things used, and the energy from illumination source being reflected from a scene element. We can see the next slide. In this, what is this one is, we could see that some scene element is getting energy from the sun. So that is being blind. Image is acquired, energy is acquired by the image. Two is the imaging system where we are going to capture the image. Okay. Third one is digital and analog circuitry sweep these outputs and converts them to a video signal, which is then digitized by another section of the imaging system. The output is a digital image as shown diagrammatically. What is a photograph? Okay, the first digital photograph is being shown to you here. The digital images are electronic photos taken of a scene or scanned from the documents. These images are composed of a pixel and each pixel is assigned to a tonal value, any kind of tonal value like black, white, shades of gray. Normally, we could have been heard that toner is for a printer. So same way, tonal value represents here the color value. Now let us see what is the basics of a digital image. A digital image is a two-dimensional function which have x and y or spatial coordinates. The amplitude of f, it is finite, and discrete quantities is called intensity or gray level at the point x comma y. A digital image is composed of a finite number of elements called pixels, each of which has a particular location and value. For example, here pixel at x comma y is if x is equal to 1 and y axis is 0, this is called 1 comma 0. What is this pixel is 4 comma 2, which means that the coordinates are x axis is 4 and coordinates at y is y axis is 2. So the pixel value here, pixel at x comma y 4 comma 2, the location is 4 comma 2. Same way it is shown for 2 comma 3. So this is an example for a RGB image location. So for example, if we say a color image green pixel, it is being described with three elements R, G, B. So it has a three coordinate. Digital image resolution is determined by the number of pixels in the image. Suppose if it is having a low resolution means it is a low quality image. Bit depth is determined by the number of bits used to define each pixel. The greater the bit depth, the larger the number of tones. A 2-bit image has 4 possible combinations. For example, we say 00100111. So if it is full 0, it is black. If it is 01, it means that dark gray. 10 means light gray. 11 means white. So these are all types of the image like black and white images, color images, binary or bit level images. Normally we say the bit level images will have only 0 and 1. Color image will have three components R, G, B, red, green, blue, the primary colors. Black and white images, black and only white, that is two combinations 0 and 1. So bit level may have some variations in the gray level also. Black and white images are made up of pixels, each of which hold gray levels which span the full range from black to white. So 2 power 256 is equal to 2 power 8. Each black and white pixel can be stored in a single byte, 8 bits of memory. So here is the color images representation. Color images are made up of pixels, each of which holds three numbers corresponding to the red, green, blue levels of the image at a particular location. Assuming 256 levels for each RGB primary level, each pixel can be stored in 3 bytes of memory. This corresponds to roughly 16.7 million different possible colors. 2 power 8 of red into 2 power 8 of green into 2 power 8 of blue. That is equal to 2 power 24. So 16.7 million. Note that for images of the same pixel size, a black and white version will use 3 times less memory than a color version. So here is the example for a binary or bit level, which has only 0 and 1. 0 is black, 1 is white. The inability to represent intermediate shades of gray limits their usefulness is dealing with only photographic images, which we can say have two states, on and off. In this slide, we can see the basics of digital image, some of the common terminologies used. What is a resolution? Resolution is the ability to distinguish the fine details. If it is having a higher resolution, information will be more clear. We can say that it is described with DPI, dots per inch, used to refer the quality of an image. A 300 DPI image could have a good quality in that we can see some fine detail very well. What is a file size? File size is determined by the number of pixels, so that it is important to know how many pixels the image contains. An image with higher resolution will have a bigger file size. A color image will also have a bigger file size than a grayscale image. Pixel dimensions. What is the pixel dimension? Or the horizontal and vertical measurement of an image expression, image expressed in pixels. For example, 8-inch into 10-inch photo that is scanned at 300 dpi have the dimension like this: 2400 into 3000, that is 8 into 300 is equal to 2400. 10 into 10 into 300 is equal to 3000. So here is the some measurement ranges given. 1 byte is equal to 8 bits, 1 kilobyte KB is equal to 1024, 1 megabyte is 1024 KB, 1 gigabyte is 1024 MB. Thank you.